Alright, hello everybody, welcome back. Carl again. Today I want to talk about my do-it-yourself Lionel Train controller. This is a wireless system. Here is the transmitter. Has a potentiometer and two normally open buttons. Over here on the desk is the receiver, which then communicates with the original Lionel pack. Now, this came in my set. This is a 3 amp pack, and you can see here is here's the transformer. It outputs 18 volts AC at 3 amps. So this plugs into the mains and then plugs into the back of this. Now, originally when I got the Train, how it worked was you would plug in that power pack back here, and then it had this wire here which takes out power to the track. Okay, so these modern Lionel Trains use alternating current on the tracks, the center track and then the outside rails. So it's really kind of hard to control. Now the way that Lionel does it is inside of the pack is actually a triac from little fuses, and that's how they're actually controlling it. Also in here is an LM324. Okay, so there's an opto isolator as well, MOC3010. The LM324 talks to that MOC chip, and then that chip talks to the triac, which puts power out to the track on one of these, see if you can see here, one of these lock-ons. Okay, so I've wanted to do this for a long time, control my train wirelessly, and I finally got the ability to do it. Now, I know what you're thinking. Well, I can buy this, right? Well, you're absolutely right. Lionel sells a TMCC, Train Master Command and Control, and that's about 150 bucks on eBay for the remote and the base, and then you need about another $100 part, or the Power Master, for conventional locomotives like I have. Now, this is let's just move it out the way here. This is a traditional, about $300 train set. I've had this for about 15 years now, and the Train Master Command Control is not compatible with this. Now, they also have the Lionel Legacy system, which is kind of the new improved, above the TMCC. That's about $300, and you still need that $100 power brick. So that's way too expensive. I just can't see. I have a $300 train set. I can't see buying a $300 remote control. So I thought, well, there has to be another way. Well, there is. So let's take a look inside here. So inside of the transmitter here, which is the potentiometer and then the two buttons, inside is a lithium-ion battery, an Arduino compatible board. This is a board that I made myself, an NRF 24L01 module. You can see just underneath there the two push buttons, and that is it. Now eventually what I'm going to do is I'm going to put a charge controller on here, so I can have like a little socket maybe on the end to plug in to recharge this battery. I just didn't see the point of having a wireless transmitter with this lithium-ion battery pack. I think is 850 milliamp hours, so that should last quite a long time. The only thing this Arduino is actually doing is reading the value of the potentiometer, reading the value of these two buttons, and then I have some future buttons that I might end up putting on the system. It reads those values and sends it out to this on an RF module. That's the only thing that it does. So hopefully it doesn't use too much power, but I guess we'll have to see. So why did I go with 50K pot? I know that's probably what you're thinking. Well, inside of the factory Lionel, inside of this factory is a 50K pot. So underneath of this wheel or rheostat is just a 50K potentiometer, and then here are just two momentary buttons. When you push them, they push buttons underneath of them. So to modify this, what I did was this black wire runs in and goes in replace of this pot. So I took this pot out, and I wired this black wire in. And this just happens to be some scrap wire that has white, black, and green. I think it's an old computer cable I cut. So that goes to the factory pot location. And then on the switches are just basically pigtail two wires and this white one, one to each side of the switch. So when this is running, the rheostat doesn't work anymore, but these buttons still actually work. Okay, so inside of this receiver, you can see there's another Arduino board that I made myself. It's getting 7.5 volts DC in. There's onboard regulation. Again, you can see another NRF module underneath here on a little circuit board that I designed. That's the same with the transmitter. This little circuit board I just designed myself. It breaks out the pins, and then I stuck a 3.3 volt regulator on there. There's two relays that act as these switches in the circuit. Again, it's alternating current, so you can't just apply direct current to it. I spent a little time trying to figure out a way, maybe if I could just use a transistor, and I couldn't get it to work reliably. So then I thought, wait a minute, I'll just use a couple relays. These are salvage relays from a board. They handle, I don't know, 3 amps or something at 125 volts, more than enough for the momentary buttons. There's 2 transistors on the board that, okay, so 7.5 volts comes from the wall. It goes to positive the relay coil, and then a high from digital pin 2 and 4 activate the transistor, which then grounds the relay and makes them work. This Arduino, what it does is it gets the data from this module, sends it to the Arduino. The Arduino does a very small conversion to take the analog reading from this potentiometer, because this is doing an analog read, converts it to a byte, which is from 0 to 255, and then writes it to a chip. Now, what I did to replace the potentiometer in here is I have a chip, which is MCP41050. That's a microchip part, and that's that chip right underneath that red wire. Don't know if you're going to be able to make it out. There it is, just underneath that red wire. And what that chip is a SPI-enabled potentiometer replacement. So pin 1 is your select pin. That goes to Arduino digital pin 7. 13 and 11 are their SCK and MOSI. You have power ground, and then pin number 5, 6, and 7 replace the pot directly. So this black wire runs to pins 5, 6, 7. So then once it gets the value from the transmitter, it converts it to a byte and then sends it out through SPI on that chip. Now, yes, I have 2 SPI devices because the NRF module works on SPI. So every time it sends that value, it turns this module off, sends the value, and then goes back to reading this NRF module. Now, if you're having troubles with some NRF modules, let me just share a couple little problems that I found. When I originally was trying to do this, I had too much going on. I wanted it to decipher the signal, and I had a couple if-else statements for these push buttons where if I pushed a button, it would say do this. If I pushed a button, it would say do that. And it was just so slow in the code that the NRF module would lose communication, and it didn't know what to do, and it would just turn everything off. So the way I simplified that was I have these switches being pulled down low. So these are usually sending lows. When you push it, it goes high and then sends a high to that transistor, to the transistor there, which then activates the relay. So it's super simple. All right, so let me get set up and I'll demonstrate the train. Okay, so I just dimmed the lights for a second. As you can see, I have power coming into my converter. This wheel does nothing. These 2 buttons do work, as I was talking about earlier. I have my receiver. See, the LED light is on, which means it's got power. And then I have the transmitter. Again, our LED light is on, and we're ready to go. Now, these Lionel trains won't work the horn unless there's voltage to the train. That's just how it works. So, what I'll do is, see, no wires connected to this. I don't want anybody to try to say I've sneaked wires. Alright, so now the key is to look at the window. There's lights in there, and that'll let you know that the train is actually has power or not. So what I'll do is, let's see if I can keep this in shot. I'll turn this rheostat, the potentiometer, just a little bit here. Alright, let me stop it, and you can see here's the lights. The train is on. And this button is the horn. This button is the direction. Now this particular one is a 3-way button. It goes forward, neutral, and then reverse, back to neutral, back to forward. So it's kind of odd. That's how this button works. I called it the stop button because essentially that's what it does. It always stops the train when you press it. The other way you can do it is to turn the rheostat down, and now that'll take it off of neutral, and then as I bring it back up, it'll automatically start in a different direction. Okay, so we'll see, we'll give it full power here, and we can hit the horn. Alright, And then what I'll just back the power down just a little bit. And then what I'll do is I'll push the red button, and that'll make it come forward out of neutral. Just the speed a little bit. And then we'll go back. And then we'll go forward. Yeah, so anyhow, so that's it. Unfortunately, I have no video of me modifying the controller here because I didn't think about it when I first did it. And to be honest, I didn't really know if it was going to work. Now, I will say this, I took a pretty good chance at modifying. As I wrap the video up, I will make the Arduino code available. I'll put the links down in the description. A couple notes. When you start playing around with this, you have to actually remove a heatsink. There's a heatsink that actually fills this back up here. And you can see there's some like little vent holes, and that's what the triac is connected to. So what you have to actually do is take that off. Then the other thing you have to do is unsolder this pot. Because what they do is they stick this pot in, and then they put the board on and then solder it from the back side. So that's the other thing you have to do. It's kind of a pain. I will say also, if you do this and you mess it up, it's kind of your fault. It's kind of another reason why I'm glad I don't have videos. This is AC electricity. Again, it's only 18 volts, but still enough to hurt you. It is 3 amps, and what do they say? It's a tenth of an amp or something will kill you. So please be careful with alternating current. The other thing to remember is I actually broke this twice, and I had to repair it. There's 2 transistors in here that drive from the LM324, I believe, and I actually burnt both of those transistors up and had to replace it. So please do be careful. I was trying to find a way of not using relays, and I wanted to use transistors, and I blew up the original transistors. So now that I know, all you have to do is inside of here is just a button. You put a wire on each side of the legs. They run to your relay, and then that'll activate those buttons. Super simple. The pot, again, you just desolder the original pot. So it's really simple, easy to do. Another thing is I had another one of these on backup. So if I blew this up, it wasn't a big deal. I have about 4 more transformers. So, it wasn't a huge ordeal. But nevertheless, anyhow, hopefully this was helpful. If you guys have any questions, ask them down below, and I'll see what I can do to help. And that's it. Thanks very much for watching.